So let's apply all of that to a problem related to this aircraft emergency. So an aircraft made an emergency landing 200 kilometers from an airport. So what we're going to do is we're going to use a coordinate plane. Here's the origin, and that's where the airport is. So the airport's at the origin, and the airplane landing, it was made a direction east 50 degrees north. So that means you start going east and then you're going to go 50 degrees towards the north. So the plane lands in that direction, where this distance is 200 kilometers. A land-based rescue team has to travel east then north, so it has to go east and then north to get to this site. So it can't do it in the direct line. To the nearest kilometer, how far would the team travel in each direction? So you need to find the x distance and the y distance. So what we're going to do is use trigonometry, and we're going to use our ratio. So this angle here is 50 degrees. It's a little bit confusing that I put it out there because it looks like it's the y coordinate, but it's not. It's 50 degrees is the angle in standard position. And we're going to use our ratios. So the sine ratio of 50 degrees is y over r, and y we don't know. That's what we want to find out. And r is 200 kilometers. So I'm going to multiply both sides by 200, cancel, and I get y equals 200 the sine of 50 degrees. And using a calculator, I get approximately 153.2 kilometers. Now the x coordinate, I'm going to use the cosine ratio. So the cosine of 50 degrees equals x over r. X we don't know, radius is 200 kilometers. Again, we're going to multiply both sides by 200. So we know the x coordinate is 200 cos 50 degrees, and that ends up being 128.6 kilometers. So the rescue team has to go 128.6 kilometers in the x direction towards the east and 153.2 kilometers towards the north. So let's take a look at those directions one more time, the applied problems related to this. We have a sailboat that is traveling south 40 degrees west for 5 kilometers. So I'm going to put the compass directions on here. We've got east, north, west, and south, and it's starting in the south direction, and then we're going to go 40 degrees west. So 40 degrees west means that this is 40 degrees. And just to give us practice, that means that this angle in standard position starts here, goes counterclockwise, so theta is 180 degrees plus 50, because this is 50 degrees here. Why do I know it's 50? Because this is 90. So 40 and 50 is 90. So we've got 180 degrees going to here, and then the extra 50, which is 230 degrees. So angle theta is 230 degrees. And we know the distance, or the radius, for this problem is 5. So this is 5. So when we're going to solve this problem, I'm going to use the triangle with the x-axis, make it with the x-axis here. And we want to find out how far is the sailboat going to have to travel in each direction. So I want to find the x value, how far is it going to go towards the west, and how far is it going to go towards the south. So the Coast Guard boat, in order to meet that sailboat. So let's use trigonometry to help us with calculating x. So the cosine of theta is x over r, and we know the cosine of theta is the cosine of 230 degrees equals x over r, which is 5. So multiplying both sides by 5, we get 5 equals the cosine of 230 degrees. And that gives you an answer of negative 3.2 kilometers. And that makes sense because x is going in the negative direction. So the Coast Guard boat will have to go negative 3.2 kilometers or 3.2 kilometers westward. Now let's try that again with how far south does he have to go. We're going to find the y value. So the y value, we're going to use the sine ratio, y over r. The sine of 230 degrees, the y value we don't know, but the ratio, the radius is 5. So y is 5 sine 230. And we get an answer of negative 3.83. Again, the negative is expected because we can see that the y value is negative. So this means that the boat has to go 3.83 kilometers southward.